Good morning, children. As we know that we are doing revision, so let's do revision of the topic matter and its state. As I already explained this in our previous tutorial class, so let me explain it one more time. What is matter? So you can see here, matter is anything that has volume and mass. Okay, that has volume and mass. Mass, its weight, right? And volume, occupied space. Fine. So what is volume? Volume is the amount of space taken up or occupied by an object. Okay, this is a can, Coca-Cola Coke can, right? So how many space this can occupied? Okay, so this is the volume, how many Coke we can filled in this can. So this is the space, right? And it is a 250 milliliter can or 300 milliliter can or 500 milliliter can. This is the volume, right? And mass is the amount of matter that something is made of. Okay, mass, that is made up of, it is made up of metal, right? So Coke, the outer structure, that can is made up of metal, right? So volume is the amount of space taken up or occupied by an object, and mass is the amount of matter that something is made of. Okay, students? Fine. Now we are talking about states of matter. So there are 3 states of matter. You can see here the 3 states of matter are solid, liquid and gas. We can also write here solid, liquid and gas. So these are the 3 states of matter. So let's start from the solid. What is solid? Okay. So look at here. This is a stone. Okay. This is a stone. A very heavy stone. This is solid. So what is solid? Exactly, we can say that solids have a definite shape and volume. You can see here it has a definite shape. Okay, it has a definite shape and volume. Volume, it's taking a space, right? And definite shape. That is known as solids, right? Okay. So in solid state, the particles of matter are very close to each other. You can see the particles, tiny molecules. Okay, tiny particles, these are known as molecules, right? So these are very closer. These are very closer to each other in solid state, right? You can see here all the molecules are very close to each other. So what they work? The solid particles hold each other very tightly. You can see here they hold each other very tightly, and that is, there is a strong force of attraction between them, right? They hold each other very tightly. Look at this. They are holding each other very tightly. That's why there is a strong force of attraction between them, right? So these are the molecules of solid. They have a particular shape and fixed shape and volume. Okay. Now look at the molecules of the particles of liquid. Okay, in liquid you can see, in liquid state the particles are packed closely together You can see here they packed closely together, but the particles in liquids are much farther apart than the particles in solid. Okay, these are much farther than the particle in solids. Okay, in solids we can see that the particles are closer to each other, and compared to the solids these are much farther, right? So these are the particles in liquid much farther apart than the particles in solids, right? So the force of attraction in liquids is weaker than it is in solids. Fine. Force of attraction also in liquid is weaker than the solids. So liquids have a definite volume, but they do not have definite shape. Fine. Liquid have a definite volume. It have a definite volume, right? It means that space occupied, right? But they do not have a definite shape, right? It's supposed to be you have a different kind of water bottle and you fill water in it, and you can see the water take the shape of the water bottle, right? So here you can see liquids take up the shape of the container in which they are kept. Fine. Liquid like any juice, any drink, you fill in any container that will take the shape of the container. It means that liquid have a definite volume, but they do not have a definite shape, right? Okay. Now come to the next, that is gas. So look at here, the boy is holding some balloons, and definitely the balloons have some gas, right? So this is gas, and here the boy is sitting near the fire, and the smoke is near the fire, that is also a gas, right? So here in gaseous stage, in gases, the particles of matter are very far away from each other. You can see here in solids, the particles of matter are very close to each other, and in liquids much farther than the solids, and in gases the particles of matter are very far away from each other. You can see the particles are very far. One is here, one is here, one is here, one is here. They are very far to each other. Okay. Now the force of attraction between particles of matter in gases is very weak. Why it is very weak? Because they are very far from each other. If they will close, the force of attraction is very strong, right? And if they are very far, the force of attraction is between particles of matter and gas is very weak. Okay? That's why gases have neither a definite shape nor volume, right? They do not have any shape and they do not have any volume. They can move here, and the gases move here and there, right? And if the smoke of a sandal blowing and mixes in the air, fine, you can see the smoke of any sandal, right? And it mixes in the air, so it has neither a definite shape nor a definite volume, right? Gases can fill the entire space or volume of a container, irrespective of the container size, right? Gases can fill, you can see here, there is an example of your home that is a gas cylinder. Gases fill in this gas cylinder, so it can take entire space or volume in the cylinder, right? Irrespective of the container size, you can see here gases can fill the entire space. Okay? So children, today we have learnt about the three states of matter. First one is liquid. We have just started from the solid, liquid and gas. Fine. So, solid, a substance that retains its size and shape without a container, a substance whose molecules cannot move freely except to vibrate, right? And in liquid, a substance that flows and keeps no definite shape because its molecules are loosely packed and constantly moving, right? They are loosely packed comparison to the solids and they move freely. It takes the shape of its container but maintains constant volume. It also occupied the space, right? So it has volume but it has no shape, right? In liquid. And gas, a substance that can only be contained if it is fully surrounded by a container or held together by gravitational pull, right? A substance whose molecules have negligible intermolecular interactions and can move freely. Fine, they are very far from each other, so they can move freely, right? So children, move on to the next, that is solubility. What is solubility? Solubility is the ability of one substance to fully dissolve in another substance under specified conditions, right? Okay, one substance to dissolve another substance is known as solubility. Okay. Now come to the next point, that is solution. What is solution? Solution is a mixture of two or more components that form a homogeneous mixture. Okay, it means that same mixture. It's form a homogeneous mixture. It means homo means same. So it's form a same mixture that is known as solution. Fine. Okay, our next point is solute. Okay, what about the solute? The substance which is dissolved is called a solute. We will take the example of these things, that is solubility, solution, solute and solubility, solute, solution and solvent. First of all, we will learn about this. So solute is the substance which is dissolved is called a solute. Okay. Now come to the next point, that is solvent. So the substance in which the solute is dissolved called a solvent, right? Solute plus solvent is equal to solution. Okay, so solvent is a substance in which the solute is dissolved, right? So we have example like salt is a solute and water is a solvent. When we mix each other, so we have a new solution, salty water, right? Okay children, let's take an example of solubility test. Here we have a glass of water in which we have poured, what we have poured? We have poured water and salt and we mixed it. Okay, that makes a solution, right? So you can see here solute plus solvent is equal to solution. It means solute is our salt and solvent is water. When we mix together, that makes a solution, right? So children, by this example, we have learnt about the solubility and solution, solute and solvent, right? Let's move on to the another topic. So children, the topic is physical and chemical change. And you know, there are three states of matter: solid, liquid and gas. So change of state, matter can change from one state to another on heating or cooling. And heating and cooling bring about changes in matter. Some changes are temporary while others are permanent. Basically, there are two types of changes: physical changes and chemical changes. So let's talk about first physical changes. A physical change is a temporary change which can be reversed, right? It is a temporary change which can be reversed easily. And in physical changes, the properties are, they are temporary. As from the name, only physical appearance of the matter changes, not chemical. Let's have some important points of physical changes. They are only in the state of matter. So, first changes that takes place in there are temporary. Changes that only takes place in the state of matter, that is only its physical properties or appearance changes, like its shape, size, color, volume, etc. It can be reversed easily. Okay, children? It can be reversed easily. So let us check out some examples of physical changes. Here we have water. When we cool water, it will become ice, right? So it's a physical change. And again, when we take ice and keep into a room temperature, and then if we boil the ice, heat the ice, it will become water, reverse. Okay, when we cool water, it will become ice, and when we heat ice, it will become water. It's reversible. And when we heat water, it's convert into water vapor. And then the fourth example is when the water vapor cooling, it's convert into water. Fine. It is totally reversible. It means that its physical change is showing. Okay, now take a beaker of water. This is example of physical change. When we cool water, it's convert into solid, okay, ice. And when the ice heated, when we cool water, it become into ice, and here you can see ice. Okay, this is a solid part. Fine. And it is changes into, when we reverse it, when we take ice and we heat this ice, it will convert into water again. Okay, so look at here the reversible process. We take ice and kept into a room temperature, fine, or we heat it, then it will melt and become water. Then when we heat it again, it will convert into water. So totally the process is reversible. It means that physical changes are showing here. Okay, children? Now look at here. The first is water in the liquid state. When we cool it, it is convert into ice, solid state, and this is a solid state ice. When we heat the ice, it will convert into liquid state. Okay? Then when we heat the water, it will convert into water vapor. This is known as the gaseous state. This is known as the gaseous state. And the gaseous, in the gaseous state, when the water vapor, when we capped a lid, a cool lid in the pan, over the pan, the water vapor is showing here. So it's also known as the gaseous state. Okay. Let's take another example of a candle. Solid wax, when we heat, it will convert liquid wax, and liquid wax cooling its solid wax. So here is the candle. When we heat the candle, it will melt. Okay, it will melt, and when we cool it, this melted wax, okay, when we heat the candle, it will melt, and when we cool it again, it will convert into a solid wax. So let us learn about chemical changes. So here, in chemical changes, heating or cooling result in a permanent change in the state of matter. It is permanent in the chemical state. Okay, a new substance is formed and we cannot get back the old substance. In the chemical changes, we can get a new substance. Okay, so let's take an example of fire. Here, the log of wood is burning, and if we burn the log of a piece of paper is burnt, it changes into ash. The molecules of paper are different from the molecule of ash. You can see here, this is burning paper and this is ash. Okay, children? So this is a chemical change. This is totally change. For other example, let's take other example. Burning of matchsticks. We cannot get matchstick back. Cooking of food and formation of curd from milk. If we form curd from milk, we cannot get back the milk again. Okay. Now let's look at the some points on chemical changes. They are permanent and they can't be reversed. Okay, and the third point is result in the formation of new substances. In the chemical changes, we always get a new substance, right? Understood, children? So let's take an example of chemical changes. We know that in chemical changes, change the amount of matter in an object, and some new type of matter is created that looks entirely different from the original matter. So you can see the example of egg. When we fry a egg, then we get a new substance, that is omelette. Okay, it will not convert into a egg again. So it will totally change. That's why it's a chemical change. Okay, let's take another example of burning of paper. If we burn a paper, when the paper will burn, it's convert into ash. We get a new substance, right? This is ash, burning of a paper. We get from it burning of a paper. So it is totally changed. We cannot get back the paper again. This change cannot be reversed. That is, ash cannot be changed back into paper again. Okay, so this is a chemical change. It's a chemical change or an irreversible change. Okay, children? So children, today we have learned about solubility and changes of matter. So there are two types of changes. Physical changes. These changes are mostly reversible, and chemical changes. These changes are mostly irreversible. So just revise your today's topic, and see you in the next science tutorial class. Bye bye.